Okay, so now that we've got actual computer processing and recording going on, it's going to start. We're going to be looking at number 2 right here. So we want to show that there's at least one value of x on the interval from 1 to 2 such that those two functions are equal to each other. So if I look at f of x being equal to equal to the x squared, and choose a different color, g of x being equal to the square root of x plus 3. Then I want to test both of these for 1 and 2. So f of 1 is 1 and f of 2 is 2. No, sorry, that's 4. If I do g of 1, we get 2. If I do g of 2, we get the square root of 5, which is greater than 2. So from this, we can see that f of 1 is less than g of 1, meaning g is on top. And f of 2, because the square root of 5 is less than 4, f of 2 is actually greater than g of 2. So now f is on top. So what we can conclude from this is that there must be some value of x for which the function on top changes to being the function on bottom. By IVT. Okay, and that's all for number 2. That's it, we're done. Oh, here's all of the work in case you need to see it for another prolonged second. Use this opportunity to pause it or rewind to go back through it. I'm gonna move on to number 3 now. Now, number 3 in class we had some issues with, but since we have it, we're going to be able to do it pretty quickly now outside of this. So what we said is that these y values, which were given to us as being between -1 and 1 on the interval 0 to 1, right? We wanted to find, let me make that not so large. We wanted to find a value of c on the same interval such that f of c squared would equal c. Now we had this 2 different ways. If we thought about taking the square root of the function, we said that would work. Because we would then be taking the square root of this business up here, because this here is the key for the problem. Okay. This holds the key. So what we did is we said if we want the value of the function squared to be c, then if we take the square root of c, we must get the value of the function. So that's saying that f of c should equal the square root. And we know that this is only true for positive values, and it will only be true on the interval we were looking at. It's only true for values contained in 0, 1. And what this means is we want our y value and the square root of our, input to be the same number. And this is only true for the values of 0 and 1. Because we can't have a negative number out of a square root. And I'm aware that that solution is not satisfying for a large majority of you, but that is all that I have for number 3. If we move on, the next one we were to look at was number 6. Okay, so we have to figure out if Rolle's theorem can be applied on the given interval and find the value of c that satisfies Rolle's theorem if it can be applied. Okay, so with this one, number 6, we have f of x equaling x minus a, x minus b on the interval from a to b. To use Rolle's theorem, it has to be continuous, which it is because it is a polynomial. And for it to be differentiable, it has to have no points of discontinuity in the derivative, which is also true. Okay, and then lastly, we need for f of a to equal f of b. All right. Well, if we plug in a, we get 0, because a minus a is 0. If we plug in b, again, we get 0 because b minus b is 0. So we conclude we can use Rolle's theorem. Okay. Give you all a second to look at that. Absorb it. Think about your questions. Pause the video, rewind, and go from there. Now, because Rolle's theorem says that there's some value, at least one, where the derivative is equal to 0 on the interval, we need to figure out what f prime of x is. And we're going to use product rule for that. So we do first d second. Well, b is a constant, so it goes 0, and then x is a variable that we're deriving with respect to, so it's 1, plus second, d first, similar thing. Our a is a constant, so we take the derivative and it's 0, and the derivative of x is just 1. So f prime of x is equal to x minus a plus x minus b. And we need the derivative to equal 0 for some number. So we need 0 to equal 2x minus a minus b. And if we continue to solve this, we'll find that a plus b over 2 is the x value for which Rolle's theorem applies and is satisfied. Okay, so for this one, what we do is we stop right here. That's it. Number 9 is similar, except it's easier. Because you look at number 9, and it's an absolute value on the interval of -3. Oh, that's a 2 for sure. So -3 to 7. Now, contained inside this interval is the vertex of the absolute value, which is at 2. The vertex of an absolute value is a corner, and derivatives are not differentiable at cusps, corners, or vertical tangents. So for Rolle's theorem, when we ask, is it continuous, we say yes. But when we ask if it's differentiable, we say no. And when they ask for why, we say that the absolute value of x minus 2 produces a corner. And corners are not differentiable so Rolle's theorem cannot be applied. And that's it for number 9. Number 19 says to apply the mean value theorem on the indicated interval and find all values of C that satisfy the mean value theorem. If the mean value theorem doesn't apply, state why. So what you have to do is you have to remember what conditions satisfy the mean value theorem such that we can use it, right? So we need it to be continuous and differentiable before we can use mean value theorem. So if we have f of x equaling x squared e to the x on the interval from -1 to 1, well, both x squared and e to the x are continuous on that interval. So when we ask if it's continuous, we say yes. If we say ask if it's differentiable, again, we say yes, because on their own, x squared and e to the x are both differentiable. So if we take the product of them, we're still going to be differentiable. Now that we have both our continuity and differentiability confirmed, we can go down and we can say that there is some value of C for which the instantaneous rate of change is equal to the average rate of change, which we use our calculus slope form for, okay? So we need to find out what f prime of x is. To do that, we need product rule. So we do first, and d second is just e to the x times 1 because the derivative of x is 1. And then we need to do second, d first, which is 2x, and then chain rule tells us it's times 1. We can clean this up by factoring out the e to the x, right? Because they both have it. And we will have e to the x, x squared plus 2x, right? And you can notice you can pull out the x as well. Okay, so now we have f prime of x. We still need f of b. Well, b is 1. And if we do 1 squared and e to the 1, we get e to the 1. If we do f of negative 1, we get negative 1 squared e to the negative 1, which is 1 and 1 over e. So our final is 1 over e. Okay, now we're going to combine it all. So we have that e to the x. Let me try that again. We have x, e to the x, x plus 2 needs to equal f of b, which is f of negative 1. So 1 over e minus what f of 1 is, which is just e, because e to the 1 is just e. And then all over, did I do that wrong? I did do that wrong. Okay, so instead of being 1 over e minus e, it's e minus 1 over e. And then it's 1 minus a negative 1, so plus 1. And this is pretty much impossible to evaluate by hand, but if you set e to the x, x plus 2, equal to e minus 1 over e over 2, then you can set the two different things equal in your calculator. So in your calculator, you're going to want to set this as your y1 and this as your y2, and then you'll calculate the intersection. I'll be right back. I've got to grab my calculator. So in my calculator, I have gone to y equals. I'll write down these instructions. So y equals was the first step I did. I pressed that button. And then I entered the y1. Let me just try this whole thing again. Okay, so in my calculator, I'm typing in my y1, and then I'll type in my y2. So give me a second to do that. X, e to the x, x plus 2, and then my y2. I'm actually going to do this fancily. If you're curious about that, you can talk to me. I'm just using the alpha y equals command to get the fraction, instead of having to think about parentheses and all of that craziness. Okay, so now I've got my y1 and my y2, and now I'm going to create my window. So I'm pressing window on my calculator. And since we know that our boundaries are from -1 to 1, I'm going to set my x min as -1 and my x max as 1. After I've got that, I'm going to change my y min to -5, just some arbitrary number that I think will be okay. And I'll set my y max to +5, just for the sake of it working out that way, hopefully. Okay. Then I'm going to graph it to see where my two graphs lie. Okay, and what you should see is something that looks similar. To this. Now, I knew that the green was going to be a horizontal line, and what I'm interested in is this intersection. That's what we want to find, because this intersection is the x value that satisfies the equation that we had. Okay? So to find out what that is, we have to do a different set of commands. We need to press second, then we need to press trace, and from there, we're going to choose option 5, which says intersect. Because that's what we're looking for. It's the intersection right here. And then it will ask you for the first curve, and you want to make sure you're on the blue. The second curve, you want to make sure you're on the green. And then you want to press yes. And the calculator will say that the intersection is at x equals 0.352. So that, I want this, okay? So this is the answer, okay? That is the one value of C that satisfies the mean value theorem. Okay. That was 19. 21 is a similar process, except it's got trig in it. Okay. So f of x is equal to x cosine of the square root of x on the interval from 0 to 4 pi squared. Okay? Now, since we know both x and cosine of the square root of x are always continuous, their product is always continuous. So we say, is it continuous? Yes. For differentiable, I'm actually going to do out the derivative for this, just to check. I'm pretty sure it'll be okay, but I'll check. So, the derivative, I do first, d second. I'm going to start on the outside, so the outside was cosine. So it's negative sine, square root of x. Left the guts alone. Now I'm going to multiply by the guts, which is 1/2 times x to the negative 1/2, because the square root is a 1/2 power. And, oops, we'll need to add second, d first, which is just 1. So we have negative sine of the square root of x multiplied by x over 2 square root x plus cosine of the square root of x. Now, this little denominator presents an issue for me, because that means x equals 0 doesn't work for me because it's undefined. But we can actually simplify it, because the sine of the square root of x, that x we can change to writing as the square root of x times the square root of x over 2 square root x, which means we'll have it cancel. We'll have one of these cancel. And the plus square root of x just kind of hangs out over there. So now we have negative 1/2 square root of x sine of the square root of x plus cosine of the square root of x. Because our domain only has positive values, then it's differentiable. So we say, yeah, differentiable. So since it's continuous and differentiable, we can now use the mean value theorem. And we've already found the derivative, so we just need to consider what is f of 0 and what is f of 4 pi squared. Well, f of 0 is 0, because x times cosine, if x is 0, is going to be 0. And then if we have to think about 4 pi squared, we're going to actually need to plug that one in and do math. Okay, so we have 4 pi squared because we plugged in for x. Then we have to do cosine and the square root of 4 pi squared. Both of those are square numbers. So what we're looking at is cosine of 2 pi. Now cosine of 2 pi is just 1. So in this one we have 4 pi squared times 1, which is just the 4 pi squared. Now we're going to use the mean value theorem. I'm going to write the derivative. Negative 1/2 square root of x sine of the square root of x plus cosine square root x needs to equal f of b, the 4 pi squared. Let me try that again and actually write the values. 4 pi squared minus 0 over 4 pi squared minus 0. Well, surprisingly, that's 1. Okay, so now we just need to find out when all of this trig business equals 1. So we go to our calculator, and we're going to do the same process. We're going to set this as our y1, and this as our y2. And we're going to calculate the intersection. So my calculator, I'm going negative 1/2 square root of x sine of the square root of x plus cosine of the square root of x, and my y2 needs to just be 1. So then I graph it. I haven't changed my window since the last time we did it. Just waiting for it to graph. Boop, boop, boop. And what I'm looking at starts on the axis and then decreases, and the y2 just happens at 1. So we have a straight line like this. So when I second calculate the intersection, first curve, second curve, guess, your calculator gives you the intersection. So the calculator says the intersection of y1 and y2 is at x equals 0. And since that is contained inside our domain, that's fine. So that is what satisfies it. This one is the value of c that satisfies the mean value theorem. Okay. '22. This one involved a bunch of logic, so be ready. So 22. Just finished 21. So the marathoner ran the 26.2 mile marathon in 2 hours, 42 minutes. We want to show that at least twice the marathoner was running at exactly 9.5 miles per hour. Or running exactly 9.5 miles per hour. We're going to show that she's been going at least one time 9.5 miles per hour. Okay? And we can do this using the mean value theorem. Because she's always been moving, right? Because it's continuous. And she's got a speed. Which is a rate of change. At all points in the interval. Okay. We want to show that she ran exactly 9.5 miles per hour at some time in the interval. Well, we know that our average rate of change is going to be the 26.2 miles, and all we have to do is do 2 plus 42 over 60 to convert the minutes to hours. Right? So if you do that math in the calculator, you do 26.2 divided by 2 plus 42 over 60, and you get 9.704. miles per hour. And the difference is that this is the IROC, instantaneous rate of change, and this was her AROC, meaning if she ran non-stop, she would have had to have run at 9.704 miles per hour. And if she started, right, so if she started the race then she started at 0 miles per hour, because you don't start a race running, you start it standing. And when she finished it, she also ended. So when she finished, she was moving at 0 miles per hour. So, since 9.704 is greater than 9.5, she would have had to have crossed that IROC she'd have to slow down or speed up through 9.5 miles per hour, giving us at least 2 times she would have had a speed of exactly 9.5 miles per hour. '23 is a lot better because you can actually do calculus. It's not conceptual anymore. It's a wonderful breath of fresh air in this entire packet of theoretical problems. And what you'll find is your test is nothing to the caliber of theoretical that these are. You should have a much better time theoretically on theoretical problems, but than you do in this problem. So this one is saying that the car company is selling cars modeled by this function. Okay, where t is given in months. So January is 1, December is 12. It wants to know during what month is the average rate of cars sold per year equal to the instantaneous rate of change of cars sold. So this is using the mean value theorem. We want to know when is s prime of t equal to s of 12 minus s of 1 over 12 minus 1. And let's start by finding out what S of 12 is. So we have 400, 5 minus 12 over 14. We can put that in our calculator to get a number. We get 800. No, forgot the 1 in front of the 4. We get 1657.142857. And you'll notice I'm using more decimals than I need because I'm not done with my answer. The more decimals I have, the more precise my answer will be, and the better chance I'll have of getting the correct answer on a free response question, because they will look at the 3 decimal places. Now for S of 1, I put that in my calculator and I get 400. I still need to figure out what S prime of t is. What I'm going to do is I'm going to distribute that 400 so that I have 20,000 minus 4,800 over t plus 2. So I can easily see that the 20,000 will become 0 when I take the derivative. And I'll do minus, so not minus, I'll do low, which is t plus 2. D high, which is the negative 4,800, so it'll be 0. So it's low, d high, all of this being d high, minus high, d low, which is just 1, over low squared, which is t plus 2 squared. So we get 4,800 over t plus 2 squared is the S prime. So what we need is we need this 4,800 over t plus 2 squared to equal S of 12, which was the 0.142857 minus the 400 all over the 12 minus 1. Slide that into our calculator to get a numeric answer instead of having to sit around and hate life in general by putting in those numbers. Crunching those numbers, I should say. And we get that it equals 114.2857 143. So to solve this, I'm going to do 4,800 divided by 114.2857143 because I'm cross multiplying, and it'll equal t plus 2 squared. Entering this stuff into my calculator to see if I get a better looking decimal. It's not. But it's 41.9 repeating will equal t plus 2 squared. Take the square root, and I'm going to go back to putting the square root of that division I was doing. And we get 6.48074 will equal t plus 2, subtract 2 from both sides, 4.481. Now I'm rounding the 3 decimal places because AP requires at least 3. That's t. So during what month does the average rate of cars sold per year equal the instantaneous? The 4th month, which is January, February, March, April. So we say in April. the AROC of cars sold equals the IROC. We could find out exactly which day by using that decimal, but you don't care. I'm not going to do it. That's the end of the problem. Okay. 24. This is a conceptual one with numbers. Again, a breath of fresh air in relation to what we have been doing. So let's brace ourselves and get through this. It says f of x is continuous and differentiable on the interval from 4 to 18. It tells us f of 4 is equal to -6, and that's the same as telling us that the point 4, -6 is on the line. It tells us that f prime of x is less than or equal to 8. This is the key part of the problem. This part is telling us that the IROC, or slope, of the line is never greater than 8. It's equal to 8 at some point, but it's never greater than it. Since we have this point, and we know the IROC is never greater than this, we can determine the absolute max by creating an equation of a tangent line to the point 4, -6. So if we use our point slope form, y minus y1 equals mx minus x1, our y1 was -6, so we have y plus 6. The slope we had was 8. X minus x1 was 4. And the x that we're interested in is the 18. We want to figure out what the maximum y value can be for 18. So the y is the f of 18 we're looking for. Add 6, we have 8, and then the x is 18 minus 4. Solve for f of 18. 14 minus 6. And we get that 106 is the absolute max. It's the absolute maximum value for f of 18. Oh my gosh. That's it. All right, 25. This one took me a second to figure out, but I figured it out. I've got it. You just need to hang on and we'll see it. This one you have to use a calculator for. There's no way around it. You just gotta, okay? So we have on 25 that the f of x is equal to e to the x over cosine x when x is greater than or equal to 0. And we have 1 plus x minus x squared when x is less than 0. Okay? And the interval they give us over here, they tell us that it can't be smaller than -1 really, and it can't be greater than -1. So our bounds, based on the graph, are -1 to 1. Also based on the picture, because it does tell us -1 to 1. Okay? So if we're going to look at -1, we have to look at this graph. If we're going to look at 1, we're going to look at this graph. So when we look for f of 1, sorry, that's the wrong color. When we look at f of negative 1, we'll need to look at 1 plus the negative 1 minus the negative 1 squared, which will give us negative 1. Then if we look at f of 1, we're going to need to look at e to the 1 over cosine of 1. Now, the problem is, which derivative do we need to look at? The answer is both. So in your calculator, what you'll do is you will go to the y equals button. From there, in the y1 area, you're going to enter that input field, and you're going to press math, and then you're going to go down and press 8 for n deriv. Okay? Now, what this will do is it'll give you a pop-up that hopefully will look like this. Okay? What we're going to do is, no matter which one we're looking at, we're going to need to put them both in here. The way we're going to do it, though, is this will be x, this will auto-populate with x, and this will also be x. Inside of this box, you're going to put an f of x, and then when you switch it over later into the y2, we're going to put the other f of x. Okay, so you put x, and then in the first field, we're going to enter, it doesn't really matter which one, we're going to pick one of these. We're going to start with the more complicated one to put in. So, math 8, enter the x, enter the function, I'm putting in the e to the x over the cosine of x, enter that final x, go down to y2, press math, press 8, x, enter the other function, 1 plus x minus x squared, enter that last x. So that's y1 and y2. Now, we don't yet have what we need it to equal. What we need it to equal is the secant information that we were using from before. So we're telling our calculator to calculate this f prime of x value, and then we are going to enter the constant value that's going to come out of the f of 1 minus the f of negative 1 over the 1. I love it when it changes the colors for me. Over the 1 minus, Jesus, the negative 1, which we said was e to the 1, which is just e, which is just e. I think I said just 1, I meant e. And then over cosine of 1 minus, go away please, the f of -1, which was -1, all over 2. So this number, we're going to enter in our y3. Yes, it's ugly, but we're going to enter it. So e over cosine of 1 plus 1, because minus a negative is plus, and then it's over 2. Then you're going to tell it to graph it. And we're going to need to change our bounds from the last problem we did. So that we can see what goes on. So I'm changing my window to be from -1 to 1. And looking at the picture, I can see that my y bounds are -1 all the way up to 5. So I'm just going to put those in the calculator and tell it to graph. In my y1, I put the orange function. So I'm going to come in here and sketch what it's giving me. Okay, that's the orange, e to the x over cosine x. The blue, the blue is the 1 minus x plus x minus x squared. And then in a completely different color, I'll choose green, and I get the line that looks something like this. That is our e over cosine of 1 plus 1 over 2. Okay, so that was y3, y2, and y1. Okay, so now when we calculate this, we're going to second calculate the intersection, which is 5. So that was second trace and then the number 5. We're going to select our first curve. I'm going to choose it to be the orange, the y1. The second curve, I'm going to choose to be the green, the y3. And I'm going to tell it to calculate the intersection. So let me change the color here. I'm going to get something like this color, purple. And it tells me that this intersection occurs at x equals 0.516, thereabouts. Okay, now remember, my window is set to the boundaries. So the area that I'm looking at is just this area, thereabouts. It's the approximate area I'm looking at. I can't see any of the stuff out here. Okay, so now when I tell it to calculate this intersection, second calculate 5, second trace, and then 5. I'm going to say that my first curve is the y2, the blue curve. My second curve is my y3, the green one. I'm going to tell it to guess, and then it's going to think about it. And even though it looks like they're intersecting in the window, I think my calculator, yep, it's going to tell me that there's no sign change. So here, my calculator says no sign change. What this means is that there's no intersection in the window. Okay, so the only value that satisfies the mean value theorem, x equals 0.516, that's the only one. It's the only value that satisfies. And that is all for 25. Now, like I said, 26, I'm not going to be able to give you a complete solution to. I just don't have it right now. And the reason why is because, based on the information they gave us, they told us that f of a equals b, f of b equals a, and b is greater than a, right? I don't know why it's telling us g, but this information right here with b greater than a tells me that we have some graph that looks like this, right? If f of b is f of a, no, if the input is a, then the output is b. Okay, let me back up. Okay, because it's different. So the y value b is greater than the y value a. So b goes up here, a goes down here. If I plug in a, I get the y value b. If I plug in b, I get the y value a. Meaning I should have this sort of line for this graph, right? Since it tells me it's twice differentiable, it's got to be continuous, meaning I can use mean value theorem. So f prime for some c, using c because that's what the mean value theorem talks about, that needs to equal the f of b minus the f of a all over b minus a. So f prime of c equals f of b, which is a, and minus f of a, which is b, over b minus a. If I factor out a negative out of the top, I have b minus a over b minus a, which equals negative 1. Okay? So, with this information, I'm completely stumped, like you guys are, on how we use this information to get to the second derivative equaling 2. Because if you take the second derivative of this, you get 0. And 0 does not equal 2. So we get stuck. And there will be a better solution coming. but there's no question like this on your test. Okay? If you have any questions, feel free to email me. I will answer them or answer you on Remind.